Dear learners, Lecture 5 on piping design will be about the codes and standards that are used in piping. So, what are the piping codes? The American Society of Mechanical Engineers, in short ASME, they have established several piping codes under the B31 series. It defines the design, materials, fabrication, testing, inspection, and maintenance requirements for piping systems that are employed across various industries. So, we need to follow these codes to ensure the safety, reliability, and efficiency in piping networks. Another system of standards and codes are given by the American Petroleum Institute API. They have provided several key piping codes for the oil, gas, petrochemical, and other industrial sectors. These codes focuses on the design, materials, inspection, and maintenance of pipelines and process piping systems. So this slide is giving you a comprehensive information about the various B31 series of codes given by ASME. Uh, the first column contains the design parameter, uh, the application, design pressure, and the design temperature. If we look at B31.1, which is applicable to power piping, the application is for the power plants, steam piping systems, and boiler feed water systems. And the corresponding design pressure will be high pressure steam and boiler systems. Then design temperature is up to 650 degrees centigrade. Next is your B31.2, which is applicable for fuel gas piping. So this this code is applicable for fuel gas piping systems, and the design pressure is medium pressure fuel gas distribution. The corresponding design temperature is minus 29 degrees centigrade to 260 degrees centigrade. Then moving on to process piping, the codes ASME codes for process piping are given in B31.3. The application of B31.3 codes are in refineries, petrochemical plants, chemical process plants. The design pressure is variable and it can also be applied to high pressure systems. The design temperature is up to 815 degrees centigrade. Then liquid pipelines, the codes for liquid pipelines are given in B31.4. They are used for the crude oil transportation, then refined petroleum, liquid, chemical, and slurry pipelines. The design pressure corresponding to B31.4 codes is moderate up to 10 megapascals, and the temperature range is usually between 20 degrees centigrade to 121 degrees centigrade. Then refrigeration piping systems, the codes for refrigeration piping systems are given in B31.5, and the application is on the refrigeration and cryogenic systems. The pressure range is up to 3.5 megapascals, and the design temperature is minus 196 degrees centigrade to ambient. The next ASME code is for metallic and non-metallic piping. So that is given under B31.6, and it is depends upon the selected material. The design temperature will depend upon the selected material. The design pressure, it also varies based on the material type. This code covers both the metallic and the non-metallic piping. Then the codes for nuclear power plants are given under B31.7. So here the design pressure will be very high pressure nuclear systems, and the design temperature is a very high temperature greater than 650 degrees centigrade. Next is B31.8. This is the gas transmission and distribution pipeline networks. and the design pressure for this codes is 7 to 15 megapascal, and the design temperature is minus 29 degrees centigrade to 121 degrees centigrade. Then the building and services piping, we normally have the piping networks for HVAC, the plumbing systems, compressed airs and fire protection in buildings. The design pressure is up to 1.5 megapascal, and the operating design temperature is 5 degrees centigrade to 95 degrees centigrade. Then cryogenic piping is given under B31.10. So this is applicable for very low temperature cryogenic piping systems. The design pressure is up to 10 megapascals, and the temperature range is minus 269 degrees centigrade to 20 degrees centigrade. Then for slurry transport, B31.11 is used. The slurry transport in mining and other chemical industries, we have to follow this ASME code. The design pressure is moderate pressure up to 5 megapascal, and the design temperature is minus 29 degrees centigrade to 120 degrees centigrade. Then exclusively for hydrogen piping and hydrogen storage, we have a code B31.12, that is exclusively for hydrogen production, storage and distribution. Here the design pressure will be high pressure hydrogen up to 100 megapascals, and the design temperature is minus 252 degrees centigrade to ambient for hydrogen storage. Next is about the corrosion allowance pipe materials and the stress analysis that needs to be performed. So for B31.1, the corrosion allowance is 1.5 to 3 millimeter. Then the pipe materials are normally applied to carbon steel, alloy steel and stainless steel. Then stress analysis we need to perform for thermal expansion, cyclic loads and seismic conditions. In the case of B31.2, the corrosion allowance is 1 to 2 millimeter, and it depends upon the gas type. The pipe materials normally coming under the B31.2 standards in the case of fuel gas piping are carbon steel and galvanized steel. The stress analysis is required for gas pressure fluctuation. Then for B31.3, the corrosion allowance typically varies from 3 millimeter, and the pipe materials applicable are carbon steel, stainless steel, duplex, uh, titanium and fiber reinforced plastics. The stress analysis is required for high pressure and high temperature systems. Then liquid pipelines, the corrosion allowance is between 0.5 to 3 millimeter, and the pipe materials are carbon steel, coated steel and high density polyethylene. The stress analysis is required for the pipelines which are buried and above the ground pipelines. Then refrigeration piping systems, the corrosion allowance is very minimal and it depends upon the refrigerant. The pipe materials normally used are copper, stainless steel, aluminum and carbon steel. The stress analysis is required for low temperature expansion effects. Then metallic and non-metallic piping, as per ASME B31.6 code, the corrosion allowance varies based on the selected material, and the pipe materials are metallic, stainless steel, carbon steel, titanium. Non-metallic materials are PVC, then high density polyethylene and then fiber reinforced plastics. Then stress analysis is material dependent. Moving on to the nuclear power piping, the corrosion allowance is based on the radiation resistance. The pipe materials are the carbon steel and high strength alloys. Stress analysis, we require rigorous stress analysis because of the radiation effects happening in the nuclear power plants. Then B31.8, the corrosion allowance is typically between 1.5 to 3 millimeter with some coatings. Then Pipe materials are carbon steel, coated steel, ductile iron, and high density polyethylene. The stress analysis is required for high pressure gas pipelines. Then building and services piping, the corrosion allowance is very minimal until unless it is exposed to very corrosive fluids. Then the pipe materials will be carbon steel, copper, PVC and CPVC. Then stress analysis, limited stress analysis is required because of very low pressure applications and low temperature applications. Then corrosion allowance for cryogenic piping. The cryogenic insulation materials are normally used, so the corrosion allowance is decided upon the cryogenic insulation materials. Then pipe materials are normally stainless steel and aluminum alloys. The stress analysis is due because of thermal contraction, because cryogenic pipelines are operating under very low temperature. So because of the thermal contraction, the stress analysis is required. Then for slurry transportation piping, it is highly abrasive, slurry impact is present. So we need to go for a high corrosion allowance because the abrasive effects of the slurry transport has to be taken care. So we have to provide a very high value of the corrosion allowance. Then the pipe materials will be carbon steel, rubber lined steel and HDPE, and the stress analysis is required for a highly abrasive material transport. Then the corrosion allowance for the B31.12 hydrogen piping and pipelines, we require some special coatings for hydrogen embrittlement prevention, and the pipe materials are stainless steel, nickel alloys and composite materials, and the stress analysis is provided to prevent the hydrogen embrittlement effects. Next is the requirements of the welding inspection, then the testing requirements and the leak detection and monitoring. So for B31.1, it is a 100% ultrasound testing for critical welding. Then we have to provide a hydro test, that is filling the tank or the pipeline with water at 1.5 times the design pressure. Then we need to go for the leak detection and monitoring tests by using acoustics, thermal and ultrasound testing. Then weld inspection requirements, we have to go for the spot radiography technique for welded joints. Then the testing requirements for B31.2 are the leak testing and hydro testing for new systems. The leak detection and monitoring will be done by gas detection sensors and pressure monitoring. In the case of process piping, we go for radiography testing and ultrasound testing. Phased array testing for the critical welds. Then here also we apply the hydro test at 1.5 times the design pressure. The leak detection and monitoring are done for using acoustic smart sensors for leak detection. Then in the case of liquid pipelines, we go for spot radiography testing and ultrasonic testing. Then the hydro test is applied at 1.25 to 1.5 times the design pressure. The leak detection and monitoring will be done by SCADA, that is supervisory control and data acquisition based real-time monitoring systems. In case of B31.5, the weld inspection requirements require the radiography or helium leak testing. The testing requirements will be pneumatic or helium leak test. The leak detection and monitoring will be done by gas detectors and pressure drop monitoring. Then in the case of metallic and non-metallic piping, so the welding inspection is dependent on the material that is being used, and the testing requirements are hydro testing based on material selection. Then leak detection and monitoring is done dependent upon the material. The nuclear power piping, we need to go for strict radiographic and ultrasonic testing. And the testing requirements are very extensive because the nuclear power plants require a lot of safety measures. Here the leak detection and monitoring will be by the radiation resistant leak monitoring. Then gas transmission and distribution systems. The radiography test and the ultrasonic test are mandatory for gas pipelines. And the testing requirements, we need to go for the hydro test at 1.5 times the design pressure. Then for leak detection and monitoring, we need to go for the SCADA, smart pigging and corrosion monitoring. Then building services pipeline, we have to go for visual inspections and the non-destructive testing for large piping systems. The testing requirements are your hydro testing and the air pressure test. Leak detection and monitoring, the basic leak detection in HVAC pipeline systems. The testing is done for basic leak detection. Then cryogenic piping systems, we go for radiographic test and ultrasonic test for cryogenic piping. The testing requirements will be the helium leak test for low temperature pipelines, and the leak detection and monitoring is done by helium mass spectrometry for tiny leaks. In the case of slurry transportation piping, ultrasonic and X-ray testing are done due to slurry abrasion. The testing requirements are hydro test for slurry lines due to wear effects, and the leak detection and monitoring is done by erosion monitoring for slurry wear detection. Then hydrogen piping and pipelines. High scrutiny is done for hydrogen piping to prevent the leaks, and the testing requirements are hydrostatic and helium tests due to hydrogen leakage risks. Then the leak detection and monitoring, we need to go for advanced leak detection and monitoring systems because of small molecular size of the hydrogen atom. So other than this, we have ASME B31.13. It is used for high pressure industrial piping greater than 68.9 megapascals, and the temperature range is minus 196 degrees centigrade to 815 degrees centigrade. Then ASME B31.14, it is exclusively used for carbon dioxide transportation pipelines. Here the pressure range is approximately 7.4 megapascal, and for supercritical carbon dioxide, the temperature range is minus 50 degrees centigrade to 50 degrees centigrade. Then hazardous chemical piping, we need to follow the codes of ASME B31.16. Here the pressure range is 10 to 50 megapascal, and the temperature is from minus 50 degrees centigrade to 500 degrees centigrade. In the case of ASME B31.17, which are applicable to liquefied natural gas and cryogenic pipelines, up to 10 megapascals and minus 269 degrees centigrade to minus 20 degrees centigrade. Then underground utility piping, ASME B31.18, here up to 2 megapascals and ambient conditions needs to be followed. Then ASME B31.15 standard is not available. Next, we move on to API codes, which are given by the American Petroleum Institute. The API code of 5L, that is the specification for the line pipes. It will cover the seamless and the welded pipes for oil and gas transportation. The design pressure will vary typically from 1 to 15 megapascals, and the temperature range is minus 45 degrees centigrade to 200 degrees centigrade. The carbon steel material is normally coming under the scope of API 5L, that is the line pipe specification. Testing requirements are the hydrostatic testing, then tensile testing, and the impact test. The failure considerations, the API 5L code considers the corrosion failure, cracking, and the fatigue failure. Then API 6D, that is the pipeline valves. This will cover the design and manufacturing of all the valves that are used in oil and gas pipelines. Here the design pressure is up to 103 megapascal. The temperature range is minus 45 degrees centigrade to 200 degrees centigrade. The materials that will be covered under this API 6D are carbon steel, stainless steel and alloy steel. Then the testing requirements, we need to follow one more code, that is API 598 pressure testing. Then key failure considerations, this code covers the valve seat leakage and pressure losses. Then API 570 piping inspection code, here it is giving us the scope of inspection, repair and alteration in in-service process piping in refineries and plants. Here the design pressure varies and the temperature range also varies. The materials that are commonly used are carbon steel, stainless steel, alloys, and the testing requirements are ultrasonic testing and radiographic testing and the magnetic particle testing. This uh, code considers corrosion, cracking and material degradation failures. Then API 574, this code is for the inspection practices of piping system components, and the scope and application of this API 574 code is for the monitoring and inspection of pipelines and process piping. Uh, the materials that will be used are carbon steel and stainless steel, and the testing requirements are ultrasonic thickness testing, visual inspection. The failure considerations under API 574 are internal erosion and wall thinning. Then API 579, the fitness for service. When we are using this code, we need to check for the fitness of the pipeline to evaluate certain defects and damage in the piping and the pressure vessels. So we need to follow this API 579 code to evaluate the fitness of the pipelines and the pressure vessels. Here the materials used will be all metallic piping materials. The testing requirements are the ultrasonic test, radiographic test, acoustic and emission testing. The API 579 considers brittle fracture, fatigue, residual life analysis. Then API 580, risk-based inspection. The scope and application of the API 580 code is for the maintenance of process piping and the inspection based on the various risk factors. Here the materials used are covered under all API and ASME materials. Here the testing requirements are data-driven probability-based inspections. That is, we have to analyze what are the risks that are involved while the pipelines are in operation, and based on that risk that may arise during the operation of the pipelines, we need to go for data-driven probability-based inspections. So the failure considerations are safety, compliance and risk prioritization. Then API 581, it's also the risk-based inspection methodology, and it is employed for piping and vessels. The API 581 gives the quantitative risk analysis and the probabilistic failure risk. Then API 590 is used for the design and materials for process piping. Here we consider the material selection and design considerations for high temperature and high pressure process piping. The materials used will be high temperature alloys, stainless steel, carbon steel, and the testing requirements are based on the ASME based testing standards. The failure considerations will be the creep failure and thermal fatigue failure. The temperature range is minus 50 degrees centigrade to 600 degrees centigrade, and the pressure range is up to 103 megapascals. Next is about the API 598. This is exclusively for the valve inspection and testing, and the standards for pressure testing of the pipeline valves is the scope of this particular code. And the materials used are carbon steel, stainless steel, and nickel alloys. And the testing requirements are hydrostatic and air pressure tests. Then API 620, it is used for the design of large welded low pressure tanks, and the scope and application are the covers low pressure storage tanks of LNG and ammonia. Then design pressure is 103 kilopascal. Then temperature range is minus 325 degree Fahrenheit to 250 degree Fahrenheit. Then the materials used are the carbon steel, stainless steel, and aluminum. The key failure considerations are the cryogenic stress failure. Then API 650, it is for the design and of welded storage tanks. So it covers the above ground welded storage tanks for oils, chemicals, and water. The design pressure is atmospheric pressure, and the temperature range is the ambient temperature range. The failure considerations will be the corrosion and stress crack. Then API 653, this code is for the inspection of storage tanks, and it provides the inspection and repair guidelines for API 650 tanks. The materials used will be carbon steel, stainless steel, and the testing requirements are ultrasonic testing, magnetic particle testing, and radiographic testing. The key failure considerations are corrosion and tank bottom failure. Next, we move on to ASTM standards, and we have a few ASTM standards like ASTM A53, ASTM A106, ASTM A312, then ASTM A333, and ASTM 335. The scope and application are especially for the seamless and welded carbon pipes for high temperature and pressure applications, then for high temperature service, then for corrosion resistance, low temperature carbon and alloy steel pipes for cryogenic applications, and seamless ferritic alloy steel pipes for high temperature service. And the key features of these standards are listed in this slide. And the scope of the material that is covered under the particular standard is also tabulated. So we also have a few other standards of ASTM. A179, which is used for heat exchangers and condensers. Then A192 for carbon steel boiler tubes. Then A213 for boilers, superheaters, and the heat exchanger tubes. Then A519, which is used for mechanical tubing for industrial applications. Then A252, which are used for welded and seamless steel pipe piles. So the key features of each and every ASTM standard is listed. Mostly it's for used for heat transfer applications, used in boilers, superheaters, and high pressure steam lines. Then used for high temperature environments, refineries, and power plants. And it is also used in automotive, hydraulic, and mechanical applications, and used in foundations, construction, and structural piling. Then ASTM A269 is applicable for chemical processing in pharma and high purity applications. Then ASTM A358 is applicable for highly corrosive and high pressure environments. ASTM A789 standards used in offshore, marine, chemical, and oil and gas industries. Then ASTM A790 used in high strength corrosion resistant applications. Then ASTM A672 is used in pipelines and structural supports, water transmission lines. Next, we move on to the ANSI standards, ANSI standards. The ANSI B61.1. Then all these standards are coming under the B series. ANSI B 16.1, 16.5, 16.9, 16.10, and 16.11. And we have a few more on 16.34, 16.36, then 16.42, 31.1, and 31.3. So all these are the standards given by the ANSI. We have a few more for the piping marking and identification, gas transmission and distribution piping, Pipeline transport is systems for liquids and slurries, then process piping, power piping, orifice flanges, and valves, threaded, uh, flanged and welded end valves. And the key features of these ANSI standards are also tabulated in this slide.